How do I demonstrate the idea of beats within PASCO Capstone? I previously connected my 850 interface. I'll click on the Hardware Setup button, and I'm going to select the voltage and current outputs for both signal generator 1 at the top, and then also for port 2 at the bottom. Once I have that data, now I can pin my display here and create a scope display to the right-hand side. On the far right-hand side of the display, I'm going to double-click on Scope. I'll want to change from continuous mode to fast monitor mode. Next, on my vertical axis, I'm going to select my measurement, and I'm going to select the output voltage for channel 1, and then again, left-hand click on the vertical axis, go to Add Similar Measurement, and then go down to Output Voltage Channel 2. Next, I need to work with my signal generator. Click on that button, and within the signal generator, I'll close down my Hardware Setup button to give myself some more space. Under Output 1, I'm going to set my frequency to 1000 Hertz. I'm going to set my amplitude to 1 volt, and I'm going to select the output settings for auto. So the signal generator will automatically turn on when I start to monitor the output from the interface. Next, down below, I'll open up Output 2. Again, I'll have my sine wave. For my frequency, I'm actually going to change this to 1002. Beat frequencies are set up when you have two frequencies that are both constructively and destructively interfering and having their frequencies very close to one another. As I did above, I'm going to click on Auto here so that the signal generator will turn on automatically when I start to monitor the data. Let me click on the signal generator again on the left-hand side to close that window. And now I'm going to click on the Monitor button. So the relationship between these two signals is a little bit confusing. So to help make things a little bit clearer, I'm going to, on the left-hand side, click on the auto scale so that we can have something that's a little bit larger. And I'm now going to select the trigger button. So what that will do is that will lock into a certain phase one of the outputs that's being displayed. So I'm not actually changing the output of the signal generator. I'm just starting when I'm starting to look at the signal. So if we look at the top here, we can see what's actually happening with the two different frequency waves. So we can see that the one that I'm triggering on is remaining steady, but the other signal is kind of marching past it. So we can stop that motion by clicking on the stop button. And you can see here at this point, these two waves are mostly in phase. However, if I click on the monitor button again, and we can have them out of phase where they're slightly different here. If I want to see the addition of these two waves, I cannot actually do that directly within the scope mode. However, Capstone has a tool so that we can export this data using the rainbow triangle at the upper right-hand side. Once I've done that, I now have a set of data that I can display in my graph. So now on the upper left-hand side, I'm going to click on my Add page. Instead of selecting the scope mode, now I'm going to select Graph. I'll double-click. On the vertical axis, I'm going to select my output voltage. Left-click again, and go down to Output Voltage 2. You can see when I selected Output Voltage 2, it toggled between the two different displays. However, if I left-click again, and instead go to Add Similar Measurement, I can display both of these voltages at the same time. My next step is I'm going to go to my calculator, and I'm going to create a calculation called beats, which is the addition of the waveforms. To pull up the measurements, I can either select the left square bracket to select the live data, and to that I can add my second output voltage. And I can also do this by right-clicking on my mouse, or if you're on a Macintosh, control-clicking, going to Insert Data, and then going down to my output voltage 2. Since I'm adding together two voltages, I will go ahead and click on volts for my units. I'll close my calculator down. And now on the vertical axis, I'm going to instead select my beats. So here we can see that there's not a whole lot of relationship here because the frequencies are so close to each other. So let's go ahead and go back to our original screen here. We'll go to the signal generator, and let's go ahead and put more of a difference on this. So let's go ahead and put a difference of 10 hertz on this. We'll go ahead and hit the monitor mode again. And we can see that these waveforms are marching past each other again. Let's go ahead and shrink down this waveform here so that we adjust the sampling rate, and also so we have more waves that are visible. We'll go ahead and stop data collection, and we'll go ahead again up to the export data feature. We'll go to page 2 again, and now we're going to select the output voltages again. Left click, add similar measurement. So we can see here that there's better matching between the peaks here and less matching on the right-hand side. So let's see what these look like when they're added together. So I'm going to click on the vertical axis and go down to beats. To get it to update with the calculation, I'll double click on this measurement again, and I'm going to reselect the output voltage. And I'll do the same for the second one, but for output voltage 2. And I'll hit enter. So now the calculations have been renewed, and you can see the summation of the two waveforms. So you can see as the waves are in phase, the sum of the amplitudes is very large, and then it's going to decrease to a point where it's a minimum. We can go back in here and increase the frequency difference still greater. Let's go ahead and make it into a difference of 20 hertz. We'll hit the monitor mode again, or excuse me, we'll go to page 1 again. One thing to note is that the frequencies of the signal generators are independent for each page, so I have to re-update that. And we'll go ahead and scrunch this down a little bit more so we have even more waves here, so that hopefully we can catch a couple wavelengths here. I'll click stop. We'll go ahead and export the data again. We'll go ahead and refresh our calculator here yet again. Okay, so we have a static display here of the two waveforms. At the left-hand side, we can see that they're unmatched in terms of phase, but as we move across, we can see them that they do get matched over here. Again, we'll replicate our calculations. Click on the vertical axis, we'll select beats, and we can see the beats that are formed between those.